All right. Okay, so let's have a look at your tutorial number 8. Okay, so tutorial number 8. So for tutorial number 8, in fact, we are covering binary files. Why is it important? Because in your assignment, if you have a look at your assignment again, let me just show you your assignment. So for your assignment, basically, there are parts that requires you to use the skills that you learn for binary file. Okay, so one of them will be a bonus given whenever you apply binary data storage in your assignment, right? That's for part 2. Part 1, don't worry, we are not going to examine this yet. Okay, your part A is basically document specification, right? So you're writing about the specification for your game. And then for part 2, during implementation, we would like to see how you store your data. So implementation of persistent storage is basically a given mark, because as long as you save a file, persistent storage is there, right? So whether it's a text file or whether it's just a normal file and so on, doesn't matter, right? As long as you save something, right? And then maximum marks will be 3 if you implement persistent storage with binary data. So binary data is what we are going to learn in our tutorial number 8, okay? So that will give you some idea on how to actually implement it, okay? And then on top of that, if you are able to implement encryption, that means to hide your username or password from public view, right? Because if you save a text file, it's going to appear in the clear, right? So it's purely textual and people can see that, okay, this is your username, comma, password, and that's not a good idea, right? So you need some form of encryption, whether it's simple substitution of characters or any encryption algorithm, like for example, triple dash or AES or whatever that you apply to it, that's fine, right? But that will be additional bonus. So that's why this is actually extra, right? It's not compulsory, but if you have it, you are going to get extra marks. So I'm going to look for all these important topics to give extra marks for you. So that means maximum you can get additional 4 marks apart from what you get for your assignment, right? So additional part 2, you will be able to get 4 extra marks. So one of them will be binary data. Okay, so let's jump to. Okay, so many things I'm doing, right? Okay, so for tutorial number 8, okay, we are going to create binary data using file input stream. Okay, so this is for reading the file. Okay, file input stream is for reading the file and the content. File output stream is to write to a file content in binary. Okay, all these are binary libraries. Okay, and then data input stream and data output stream also works about the same way. It's just the method that you call it will be different. Okay, so over here, if you look at this example source code given, all right, you might have seen this before. This is try with resource, right? Try, and then there's a bracket for something that you're going to do with the try, right? And then inside this try, you are actually accessing resources. The first resource that you access will be file input stream. You're creating a new file input stream object from this instance, and the instance is actually pointing to the current folder and with a file name, right? The file name is source.jpg, all right? Source.jpg is one. Then the next one is destination.jpg. So all these are the resources that you are going to try to open, right? So first thing, if you open the file for reading, if it's successful, the file input stream will be okay. If not, then this try will fail. Then you would go to the catch statement below, all right? Do you get this? Okay? So the try with resource, of course, will allow you to actually try and catch error, all right? So, and then this line shouldn't be here because the try, okay, yeah, sorry, it is here. So because the try here, there's a bracket. This is for the while, and then this is for the end of try. Okay, so remember that if any of those things like file input stream or file output stream fail, it will jump to catch. All right, so let's try to create this program, and I'm going to illustrate the creation of this program using Visual Studio Code. And one important thing about Visual Studio Code is that you have options to actually create using so-called project manager or not, right? So let's create it. I'll just run Visual Studio Code from here. Okay, and there are multiple things here, so I'll just close this one. Okay, so we'll start from scratch. Okay, so now we want to create one for tutorial number 8. Okay, so let's start by pressing Ctrl+Shift+P, and then you are able to actually create a Java project. Doesn't matter whether you use other IDEs such as Eclipse, okay, or IntelliJ, or even NetBeans. That's fine, because the steps will be about the same. You just need to create a normal Java application. So if you create a Java project here, you have a number of options to choose from. So some will be project manager based, like for example Maven, Gradle, Spring Boot, and so on. But we don't want to use any of those project manager, like for example Maven, that allows you to create the architecture type accordingly, right? So one good thing about using Maven is that it allows downloading of libraries or dependencies automatically, right? You don't have to download any of those libraries anymore, right? But the thing is, of course, we don't want to use it all the time, right? If you are creating standard Java project, you don't have to. So you can actually start with the no build tools. That means a standard Java project, as in NetBeans, okay? NetBeans, there's a standard Java application. And then you just need to choose the folder that you want to use for your creation of your Java project. So what I'll do is I'll do this inside my documents, Java. Okay, so this is my standard folder. I'll choose my Java folder here. And then next you need to give the project name. So this one I'll call it as tutorial 8, okay, TUT8. Okay, and then it will automatically generate a template for you. And this is your tutorial 8, the main folder, all right? And then followed by .vs Code is basically for settings of Visual Studio Code. So it will normally not appearing in other applications, okay? And then there's a library folder as well as a source folder. So the source folder is what we are more concerned about, because this is where you're going to write your application, all right? And the standard application that it will generate is called app, okay? App.java. So you can just ignore this one, okay? We don't need the app.java, but rather I would like to create this particular application. You can just grab the code here for experiment, okay? And then take note that this is called binary file copy, right? The first thing that we want to learn is binary file copy. So you can start with a new Java class called binary file copy, okay? And when you press enter, it will generate the standard template for you, right? The public class binary file copy. But in order to actually create a complete program, this is what you need to do. Just make sure you copy the source code. And if you want to format the screen for Visual Studio Code, you just press Alt+Shift+F. Then it will format the screen nicely for you. All right. And over here, you need to actually have two files. One is the source.jpg. The other one is the destination.jpg. So that it's able to copy the file, right? So let's compile this program and run it and show you in case if there's nothing, right? No files. So by right, it's expecting the file inside the same folder as your readme.md. Okay, so this readme.md is basically a documentation for your file, right? And if you are using things like GitHub and so on, it will appear as though it's a web page, right? That you can read through. But normally you don't have to worry about this. Okay, so over here we have this file, and if you run it, it's going to give you error. Why? Because the content called source.jpg is not available, right? So therefore, if you try it, this is what you're going to get. Okay, you notice that if you try this one again, okay, if you try to run it, it gives you the error saying that file not found, right? Okay, source.jpg. So let's grab a source file, right? So maybe from your pictures or whatever, I'm going to grab my face, okay? I'm going to grab steve.jpg over here, copy it, and where to put your file. So you need to basically go to the source folder for tutorial 8, okay? So one thing is, if you want to open the source file, you can just right click on either one of the folder, just say review in file explorer, okay? And then this is your bin folder, right? So your tutorial 8 folder, right? You just right click, and then this is your standard folder. You just need to place it here, right? Steve.jpg, and make sure you rename it to source.jpg, right? Because the first name for the input file is called source.jpg, right? Okay, so source.
I can copy the path of Steve.jpg and then paste it.
Yeah, any JPG file, right? Any JPG file, existing JPG file, rename it to source. All right, so that you are able to basically copy this file. So let's have a look at Steve.jpg. This is Steve, okay? Right. So now confirm everything is in place. We have the source file in your tutorial 8 folder, right? Tutorial 8 folder, right? And then next, once the file is there, when you run your application, it will be able to copy the file. So now the source file becomes destination, okay? There's a destination file here, right? No more error. File is copied successfully, right? Okay. So file is copied successfully will be printed in case if the try everything is okay, right? So then no error and your destination file is the same, right? As your source. Okay? So that is for file copy, right? In case if you need to copy and save any files in binary, right? So take note that the process involved in copying file is very straightforward. All you need to do is just create a file input stream and file output stream. And for every data in your file input stream that you read, you are going to write it one by one to your file output stream, okay? So remember that, okay, over here, data assigned fis.read is basically for us to check each and every individual data bytes that we read. Is it equal to -1? Okay, the status that is going to return is either a byte or a -1. If you get a -1 for the status return, that means this is going to be an indication that is end of file, okay? -1 stands for end of file, EOF, remember that, okay? And then for every data that you read, then you are going to use FOS, file output stream dot write, and you write the individual data in integer. Integer is how many bytes? 4 bytes, okay? 32-bit, 4 bytes. Remember that, okay? Each integer is 32-bit, 4 bytes in terms of the length. So we are actually reading 4 bytes each, right? And then you write to your source, write to your destination. And once the destination is written, then you notice that it's the same file that you have created, right? Okay, so the first part on copying of binary files, are you okay with this? So it's very straightforward, right? Very simple. This is one of the simplest application or simplest program that you can actually write, okay? That is to actually copy a file. The second part that we want to learn is on how to write integers to a binary file. So we are going to write integers. Integers are 4 bytes each, right? 32-bit. Okay, so if you have a look at this program, what I want to tell you is that, okay, over here, instead of using data input stream for file copy just now, right? So we are using data output stream only because we want to write a file, right? So if you are going to save your game or save your data, you are going to use either data output stream, okay? So remember that previously we used file input output stream to copy the entire file, right? But if you want to just write some data to your file, then we use data output stream instead of data input stream, okay? So the file one is meant for the entire file. The data one is for you to do it based on what data that you have, okay? So we are creating a data output stream instance called DOS, and then this is a new instance of data output stream using a file output stream. So when you say using a file output stream, you are supposed to refer to a file output stream object so that it's able to know the file name and the storage being reserved for that file, right? So over here you have to create a new instance of file output stream, but you don't actually have to name it, right? So this particular instance, you don't have to name it. You just need to say new file output stream with the file name called integer.bin, all right? So, and then for the integer.bin, must the file be there? No, right? Because to write a file, it can actually create a new one, all right? So like just now, we need to have the source.jpg, but not the destination.jpg, right? Because the writing is automatic, right? When you write a file, if it's not there, the writing will be successful. But if you try to do it twice, what will happen? Okay, so just now, some students might be asking, if I do it twice, what will happen? Okay, so nothing will happen. In fact, as long as the file is there, then it's fine. You can just move it to somewhere and then you run it again. Then the file will be created. Okay. So if it's already there, it's just going to be overwritten anyway. Okay. Right. So you notice that if you run it, okay, no error will be presented. You are going to return back to where you are. All right. Okay. So it's still file copied successfully, right? Even though the file is already existent, right? So the file exists, then no issue, right? It will still copy that. So over here, let's try to do the second application. You notice that I can actually create all these files inside the same project, right? The same so-called project that I've actually created just now, called tutorial 8, right? So I can create another new source code here by just right-clicking, new file for the new class, and this is what we call as write integer program, right? So you just need to say write integers, right, for the Java file, and then next paste the code inside, press press alternate shift F, and then it will format the files for you. And take note that what we are going to write here, after you have opened the data output stream resource, so the resource has to be put inside a try, just in case. If it fails, then it's going to go to the catch statement, right? But if it's successful, it's able to create this file output, then it will proceed with doing this thing. In a for loop, we are going to initialize an integer variable I with value 0 up to 10, right? In fact, you are going to have up to 9 only. Why? Because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 will be less than 10, right, in this loop. Okay, so this for loop will run for 10 times, starting from 0 up to 9. Okay, from 0 up to 9. And then what you are going to do is you are going to use the data output stream to write the integer. In fact, you can write many, okay, for data output stream, you can even write integer, write UTF, or write just a byte array. Okay, you can even flush the content, write single character. Okay, so for the write, in fact, you can write integer, write UTF, write character, as well as many of the other writes that you can actually implement, right? So like for example, for write, you can even write double, write boolean, write bytes and so on, right? So there are so many data structure that you can actually write to a file. But you notice that when you write this, it's going to be continuous, right? You won't be able to see how they are being formatted, okay? So let's try to write integer first, and then I'll compare it with writing a char later, right? Or you want to see write char first. So let's write integer first, okay? I'll explain about integer first. Then later on, we are going to see how the other things like write char, write boolean, write long, write float, or write double will appear. Okay, so when you run this program, as I mentioned to you, you do not need to actually create a file, right? Because this output will be generated and then it will normally create a new file if it's not there, okay? So this new file is called integers.bin, right? So once you run this app, you notice that no error, then nothing will be displayed, but you will notice that there is this file called integer.bin, right? So the integer.bin, when you click on it, the system will say that, okay, the file is not displayed in the text editor because it's either binary, right? Or in an unsupported text encoding, that means it's a binary format. So you can open it anyway, but if you open with text editor, what are you going to see? A bunch of unknown things, right? Like now, whatever, right? So if you open it directly as a text file, you cannot read the content, right? So then you are by default concealing the data, right? So the data is concealed in binary format that only you yourself, the creator, will know the structure, right? So the structure consists of 10 integer bytes, right? So those are what you need to actually know. In fact, if you don't know, you won't be able to read it successfully, all right? So again, if we open this integer.bin using a hex editor, then you can see the content, in fact. So over here, you have the second option, choose hex editor. And in the hex editor, you will be able to see all this byte format, right? So remember that integer is 4 bytes, right? First byte, second byte, third byte, and the least significant byte is here. right? So this is a value 0, right? If you look at this 4 bytes, agree? Value 0, and you look at this 4 bytes, value 1, agree? Then value 2, value 3, and so forth, right? Until value 9 below, agree? So that's why it's in binary format. The only way we can read binary file is by using a hex editor, right? A hex editor will allow you to see the bytes in hexadecimal. So since it's in hexadecimal, every 8-bit will be converted to 2 hexadigits, right? 2 hexadigits to represent 8-bit. So that's why we have 8 hexadigits here, all right? And then the last one, a plus symbol denotes the end of file, right? EOF, end of file. Okay, so this is the binary file structure. Is it okay for you? All right, so since we have already mentioned about the binary file structure, right? This is integer. How about when we write it as a char then? Or we write, okay, let's write a char instead. Okay, so the file is already there, right? But if you run this program twice, what will happen? It will still be writing to this file, okay? And no errors are displayed. Let's have a look at this particular integers.bin. If you write a char, will it be readable in your text format? No, right? Okay. Next, if we open it in hex editor, take note that the file size now is smaller, right? Okay. So the first one is 2 bytes. Okay. Since we are writing a char, 2 bytes for the first character, 0. 2 bytes for 1, 2 bytes for 2, 2 bytes for 3, 4, 5, 6, 7, 8, and 9, right? Okay, instead of 4 bytes just now, integer, 4 bytes, 32-bit, all right? So if you want to save some space, you might be using write char instead, okay? Right? Okay, now the file size becomes smaller. How about if I use a crazy way, write byte? Okay, so write byte will write 1 single byte, right? Okay. So what will happen is that, okay, now if we do it that way, you're going to write byte by byte. And if you look at your content now, I'm going to just open with hex editor, right? So now it's 1 byte each. 1 byte, 1 byte, 1 byte. Smaller, right? Even smaller. Okay, but that will be applicable only to small numbers. Agree? If your number is big, for example, if let's say you try to increase the size of this one, instead of from 0 up to 10, let's say if we say 100 up to 110, what will happen? So take note of this file initially, all right? And then when we run this app again, what happens is that now, okay, the file size will still about the same, right? 100. So now the number becomes D, E, F, G, H, I, J, K, L, M, right? Whatever. But if let's say this is 1000 and above, what will happen? Okay. So I'm just going to illustrate to you. For some bytes, that should be okay because it is still contained within the 2 bytes limit, right? 1000, I think it should be okay also. Longer now, right? Do you get it? So it won't be efficient if you are going to write char or bytes for a large number, right? So char or bytes for large number, it becomes too big, right? The file now is so long, right? So what should we do, in fact? If it's a long number, it's better for you to write an integer or write a short, okay? But we're going to write an integer, and you can see, let's compare this. This is actually up to, okay, line number 60, right? So over here, line 60 something, right? Let's see. If we change it to integer, same data that we write. Okay, this is even longer, right? So if it's integer, it's even longer. So you might want to just change it to some shorter format, right? Like writing. Okay. So over here, you have byte or bytes to write, right? So, and then write char or write chars, float or double, all right? So let's say we try it with a float number instead of writing an integer number, right? Okay. So float is how many bytes? Okay. So a float, of course, will be about the same size, right? So let's write with the proper format. Let's write char, okay? And then let's see how different are they compared with what you have just now, right? When you write integer, it seems to be quite long, right? Okay, because you are writing 100 numbers, sorry. It should be 10 number only, right? Okay, so instead of 100. Okay, so let's see. Now if I write a char again, 10 chars, that's 10, right? And if you write integer, 10 integers. So that's for 10 integers. So you notice that now the numbers, the last 2 digits will represent the integer number. And the good thing about integer is that if let's say this is 1 million, okay, another 3 zeros behind, okay, and this is 1 million up to 1 million and 10, right? So you notice that there's no increase in terms of size. The size is up to 20 something only, right? The row 20 something, okay? So let's see. Okay, yeah, it's longer, but sorry about that. But you notice that, well, the numbers are only 20 something also, right? 1 million. Also 20 something, right? Same. So it doesn't matter what number you save, but you can see that the numbers can be represented more efficiently using binary, right? Okay, so rather than using single characters, of course, the size will increase. Agree? Okay, so remember that for large numbers, you might want to use binary data storage, which are more efficient as compared to your character, right? If you are going to save it as a character, how many characters are there? 1 million. 7, right? So the basic ones, if you save 7 characters, it will be how many bytes? 7 bytes, right? 7 bytes. Compared it with here, only 4 bytes each. So for the first digit, 4 bytes. Okay, which is more efficient, 4 bytes or 7 bytes? 4 bytes, all right? So hopefully you get the idea. So once you are clear with this one, this is for writing a binary file. How about reading a binary file? So whatever you have written here, the third example is for you to actually read the content back, okay? So since we are writing integer, so that we can actually read in any format, as long as you know how many times you have to repeat, okay? So this is a prerequisite. If you want to actually read a binary file, you must know its structure, okay? So here we are actually writing one single data type, right? So it is basically monotonous, right? Unlike if you write in heterogeneous way, you can actually write files in different format, right? But it's binary, all binary, okay? So like for example here, we are writing integer continuously, 10 integers, right? But the next example actually shows you how to write in a heterogeneous way. So here you are writing the format UTF, hello world, okay? And the next format is even more interesting now. You're writing multiple kinds of data, all right? So up to sample 5, you're writing multiple data, okay? So here we are actually showing you how to read the homogeneous data that we have actually created just now in part 2, right? So let's see. If we create a new Java file called read integers, right? So read integers. And then what we put inside the read integers will be this one, right? And it doesn't matter whether the loop just now starts from 1 million up to 1,000,001. Here, we still need to just repeat 10 times, okay? So you can just use the same one, and you are able to actually read back the integer just now. So now that this is ready, let's run this app. And you can see that it's able to read 1 million up to 1,000,009, right? 10 integers, right? So, but the loop here need not be 1 million up to 1,000,010, right? So over here, do you get it? So the loop is 10 times, as long as you remember that, okay? Loop 10 times and read 10 integers, right? But the right here, because we want to use this value, so therefore we start from 1 million up to 1,000,009, right? Do you get it? So that's the idea, in fact, for this particular loop. You need to know the structure well, okay? So the third example is basically for reading homogeneous integer data. So how about the next one? The next one is to write Okay, so this is for you to actually write the data. And for this one, we are going to write and read together, right? Write and read the so-called UTF strings. Okay, so this is for writing strings. So since we are going to write in string format, so let's write this code over here. So this will be write, read, string, right? And then we are going to put the code here. So sorry, not strings. Okay. So anyway, we can just rename it and then save. So this becomes read write strings. Okay, read write strings. And once it's done, the first step is in fact to write a string, right? You notice that we are using the same format, the try with resources. First part is to write two data, hello and world, right? Hello world. And then take note that when we use write UTF, the strings that you write is basically going to be HELLO followed by WORLD, right? So let's run this app, and then you can see a new file has been created called strings.bin, right? So when you run this, strings.bin will be created. Okay, if you open up strings.bin, you notice that the data is actually continuous. Hello world, right? But this is in text format. When you read in text format, of course, it comes with additional symbols and so on, right? So let's open it using hex editor. Then you can see that the hello world is supposed to be like in this format, right? So this is HELLO world. And you notice that there are two symbols in front, right? 05 and 05. What does that mean? So because you are writing UTF, UTF needs some symbol to represent the so-called character code, right? So the special character code, and it is able to actually show all kinds of universal type font, right? Like for example, for Arabic, for Chinese, and so on, you can actually be able to show those characters as well. But you need to actually indicate what characters are there. So therefore, these are the additional two, right? But if you write just char, then you will be able to see that they are about the same thing, okay? So over here, you are writing UTF. If you write char, what will happen? Okay, so let's write the char here. But you need to actually have the, sorry about this. Write char. And it should be write chars. Okay, my typo. Write chars. So you're writing characters now. And then when you read back characters, see what you're going to get. Okay, so this is just to okay, so you can in fact use read fully or read all bytes, okay, to basically read the data. So since you are writing a char, okay, let's see whether we are able to actually read it properly using the correct byte. Okay, so one is 4 bytes integer. The other one is, because this is going to be written in another format, so therefore, let's use read instead, okay? And then it won't be able to read a string. So in order to read a string, we will have to basically look for read line is out, sorry, and then we use read UTF again, okay? So let's see whether we are able to read the same thing. Okay, so over here it generates an exception, okay? Because your read UTF is not able to read the string that we have just now, right? If you look at the file, how is the file going to be written for your data just now? Okay, so if you look at your strings.bin, it's hello world, right? Each and every one of them will be 2 bytes. Okay, so therefore you need to actually read 2 bytes instead of reading the one just now, right? Okay, so if you do write chars, this is what is going to happen. Write chars will write it 2 bytes each. Okay, 2 bytes, 2 bytes, 2 bytes until the end. Okay, so be careful about this, because if you're going to compare this with the write UTF, right? Write UTF will do something extra. Okay, write UTF. If you use write UTF, let's see, the format here is up to 10, 11, 12, 13, 14 characters, right? So when you use this, okay, it's only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so one line only, right? Compared to the previous one. Okay, and the indicator is in front. So it's more efficient for you to use UTF, right? UTF is more efficient because it identifies the string, and then this will be the string continuously, right? One string after another. Okay, so remember that. And then the next example is mix, right? The next example is mix data. This is the one that you need to learn because you are going to apply the skill, right? For example, you want to create a save game file, and then the first data that you save will be, let's say, your user's value. Like for example, in your game, okay, how many points you score, okay, and then you can even write double value, and then followed by, let's say, the username, for example. Okay, so this is an example. Let's see, when we use a mix read write, can we read back the data? Of course you can, right? So by creating a new Java file called mix read write, and then what we do here is we put the code into it, and don't forget to actually close, right? I forgot to close the, okay, complete all the braces, everything, and then it should be okay. So this file, binary file, is called mix.bin. If you create it, it's going to be consisting of 42, 3.141592 followed by Java, right? So let's run this app, and then you can see the file called mix.bin being created. Okay, so now here this is mix.bin. If you open it up in binary hex editor, then you can see that the last 4 words Java, J-A-V-A, is shown, right? Java, each of them will be 1 byte. And then this is the end of file. And then the one in front is basically going to represent what? Value 42. Okay, 42 is represented by what? Okay, so if you want to know how do we represent value 42? 42 is written as integer, definitely it's 4 bytes, right? So this is 42. In hexadecimal, it's 2A, right? So remember that 2A represents 42 in binary, right? 42 in binary for integer, 4 bytes. And then the rest, this will actually represent your float number, right? Sorry, double, right? So remember that we are actually looking at a long value that represents 3.14 something, right? Pi, the value of pi. So if you look at your source code here, this is double, right? Double size, not float, double. So 3.14 something will be represented by these characters, right? So it's more efficient, right? Anyway, the value can be as large as possible. So don't look at the small values and think that, okay, why don't we use, smaller storage? Like let's say if I use char to represent 3.14 and so on, why not, right? If you can anticipate that the size is always small, then use char. If not, then use float, right? So float will be more consistent because the size is fixed, all right? So here, how many bytes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so all these are representing your float number. Okay. Okay, so hopefully you get the idea. You can write in mixed format, right? And then you are able to read it back. You notice that by using the following. I initialize, firstly, if you look at the source code, right? Inside the try with resource, I initialize integer value with dis, that means data input stream dot read integer. And then next you read double. So the sequence is important. If you read the wrong sequence, you get the wrong data. Okay, so you read integer first before you read double, then you read UTF. So therefore, it allows you to actually show the number. Right? Is that okay? So remember that UTF will have 2 bytes in front to represent the text format, okay? Right, so if you look at the source just now, the 2 bytes in front is in fact used for representing the format, okay? So that means before this 2 will be used for representing the format for Java, write the word, okay? And then this will be used for representing your float number, double, 1, 2, 3, 4, 5, 6, 7, 8, 8 bytes, okay? Instead of 4 bytes, 8 bytes double, okay? Right, so is that clear? Okay, so here we go. Once we are okay with this one, that allows us, in fact, if you have learned this one, you can actually use this routine to start writing your data, right? Save your save game, right? So since we are able to actually write, you should be able to also use data. So this is for data input stream, okay? So you can use this routine here to read the data file, right? And then to write, you use the routine on top. So I'm just combining them both so that you are able to understand in one particular program, right? But if you want to just write the routine for, let's say, for reading, the reading one is below. This is for writing. And then the reading one will be here. Okay? All right? So read and write provided. So you should be able to write your application set right to a byte. Okay? Write to a binary file, sorry. Then next, how to write binary array or byte array in this case. So the byte array has to be declared as a byte array first. Okay, so this byte bracket simply means it's an array of bytes. Okay, array of bytes. Okay, so the data type is byte, and then this is data. And then for byte array, you can basically initialize the value inside a curly brace separated by comma. So each and every one of them will be 1 byte. Okay, 1 byte each. So if you try to run this or write this program called byte array IO, you notice that you will be able to write the data in bytes. Okay, so I'll also demonstrate this one for you. So here we are going to actually have write the name is just now called byte array IO, sorry. Byte array IO. Okay, and then we put in the source, the code here, and you notice that we are able to now write the byte. Okay, this is the byte that we actually initialize, and then after that, you are going to actually read it back. But before we read, you notice that it's also important for you to know the bytes size. Okay, over here you need to actually create a byte array called read data and initialize it with a size of 6. If you don't know the 6, okay, over here, you won't be able to read it successfully, right? Because you are going to read more or less, and then you get error, so-called erroneous data. Okay. Now, let's run this program and see what is going to be written to a file. So the value written, in fact, is 0, 1, 2, 3, 4, 5, and then when you read it back, you are actually adding a space for display, right? So here 0, 1, 2, 3, 4, 5 is actually being displayed with a space. All right, but if you look at the actual file, so the so-called binary bytes.bin, okay, if you look at the bytes.bin, these are the bytes written, 1 byte each, okay, 0, 1, 2, 3, 4, 5, right? Nice, right? So this will be 1 byte each. If you really want 1 bytes each, this is what you should do, right? Using a byte array, and then just write the individual bytes accordingly. All right? So is that okay for you? So remember how to actually read and write the bytes, okay? So this is for byte. You need to initialize the byte array with some data, right? Or you allow user input byte by byte. Next, when you read it back, you are going to initialize a byte array also, but you need to know the size. So the challenge will be to know the size, all right? And most of the time, how do we know? Save those information in a settings file, right? So that you are able to retrieve back. Like for example, okay, how many bytes are there already? You don't know. You put it in a settings file, okay? Then you read, okay, the value is 6, then I just read 6 bytes. That's it, right? So remember that there are ways to actually overcome those problems, like unknown byte size and so on. So that can actually be saved in a settings file somewhere, all right? So the settings file can be just a normal text file, as I mentioned to you. For convenience, you might want to consider normal text file for the settings. All right. And some people use, like, for example, JSON or whatever format. That's allowed, no problem. And the last one, the last example here is basically object IO. This is the one that I will recommend you to do. Okay. So when you talk about object IO format, so we have learned object-oriented programming all the while, right? Do you know that the data, okay, did you know that the data can actually be stored as object? The entire object in your memory, in your object class, right? The class that you declared, you can save the entire content into memory or into your persistent storage. So how to do that? Let's do this first. So the first part of this code is actually a class, right? A class file. But take note that the class file now is actually implementing serializable. Okay? So if you implement the interface called serializable, the data of that particular object file or object can be stored continuously, right? So now the object can be stored continuously. You will be able to actually retrieve it back from a file or write to a file. Okay, so remember that for your class implementation, you should actually also provide this implement serializable. Let's do this first. Okay, so I'm going to create a file, a class file called person. Okay, and then in the person class, I'm going to actually have this implements serializable. Okay. So why do we want to implement serializable? Is when you implement serializable, you are able to actually write or read those entire so-called objects, right? The entire class objects to a file. So this is what we wanted. And now let's do it. Okay. So remember that when you implement serializable, there's one part that you must override. Okay, there's a method that you must create. In fact, you must implement. That is called the toString. Okay, the toString method must be implemented so that you are able to return the entire object value, right? So the object value like name and age can be returned in one line. All right. So, but this will not be 100% useful, right? And still remember that when we create our so-called class file, we could have actually implemented the getter and setter, right? So the getter and setter you can just implement in your class as usual, right? So how do you implement it? You just do the normal way, like for example for the getter, okay? So if you want to get the name, you will create a public string method. Okay, if you don't put the word public, it's by default public, and then we say get name, right? And then you need to return the name. So that will be the getter for the name. How about the getter for your age? So we have a get age method again, and then it will return age. Okay, so with these two methods are available, you are able to actually read and write the object value now, right? So this one is for you to read. For writing, of course, you need to implement the so-called set name or set age. All right. So this is normal thing that you learn in your OOP, right? But we now add in the implement serializable only, right? So this keyword implement serializable will allow one wonderful thing to happen shortly. Okay, I will show it to you. So then this is your override method that you must implement toString. Okay, if you don't implement this method, what will happen? Oh God. So anyways, it is actually safe. Okay, this is actually saved. So whenever your screen is out, please let me know. I don't really like the screen here. 702 is always getting disconnected and it's very irritating. Okay, and you can't see the screen anymore. Right. Anyway, I'm going to upload this recorded video so that you are able to see it shortly. Okay. So this is a bad idea. And where's our C702? C702, where is it? Okay, here. right? Okay, now it's connected. So remember to actually implement this toString so that you are able to actually read the entire object, right? Okay, so now after you have implemented serializable, now one wonderful thing can happen in the sense that now if you try to use your object like the following code, okay, let me just create another code over here. Okay, so let's create another application called object IO example, right? So this will be your next Java class called object IO example, and then you need to import okay. So if let's say you now put in the code for this one, object IO example, I think my typo is wrong, so don't worry. Okay, here we go. So object IO example, once you have actually imported Java IO.star, every one of the object available called object output stream or let's say file output stream and so on, they are all available, right? So let's see. Firstly, we declare an instance. Take note that the instance that we created is called person, right? So we create a new instance of person called person, small letter, and then we initialize it with a value John 30, right? Oh gosh, this is irritating, right? We want to continue on with the lecture or the demo, and the system is always not complying.
I think that's all.
No, right? No, I will have to finish this.
Is it important?
All right, because this is important. I'm recording it, and I have to share with the rest of the group. Okay. So, right. So once we create the instance here, the instance can actually be written directly to a file by using object output stream.write object. So the entire thing will be written to a file, and that file name is called person.bin. Remember that whenever you use the try with resources, it allows you to create a new instance of, let's say, certain output stream, right? Whether it is data output stream or file output stream, then you need to actually specify the file name, right? If it's file output stream, it's already specified here, but if it's object output stream or data output stream, you have to create a new instance of that file object to say the file name, right? Okay? And then what happens is that now we are able to write this file called person.bin. Now inside here is no longer, it's not in existence yet, right? Until when you run the app. Then next you're going to read it back, and okay, what I'm going to do here is instead of system.out.println data, right? I can actually do a read person dot get age or read person dot get name, right? So over here you're able to actually get the name and get the whatever. And obviously this is just one part. In fact, if you notice, because it's in object format, whatever data structure is already declared, right? The age and name can actually be read. Straightforward, right? And you don't actually have to do conversion, right? Like in the previous example, you must know the data structure well, right? In order to read the data. But here, you can just use system.out.println to print the data. And because it's already known, you have no issues, right? You can just directly do that. Or you can actually use the method, the getter and setter, and print out the data, right? If the variable is available, of course, you can just print the public variable directly from there, right? If not, then you just use a getter or setter that's provided in your class, and then everything is done. You don't have to worry about the data format, okay? So now, let's do it. Okay, so before that, let me just move it up a bit. And when you run this app, okay, it shows you 30 and John, right? 30 is the age, followed by John, right? Do I actually have to format the so-called data file, person.bin? Let's look for the person.bin. So person.bin is here. We open it. So you notice that it's entire class, right? So all those things are things that you don't really understand, right? The entire class data is stored here, including the age and including the name of the variable. Okay, the variable names and the age and also your so-called name, which is called John, right? The last four is John. But it also includes the structure of your data, right? Like let's say this one is of type string and it's called name, right? So the entire object is safe. And when you load it into your memory, you can just immediately use it, right? Because it's already in Java object format, right? And since it's in this particular object format, right? So you can just initialize a class called person, right? And then from here, we use read object, but you must cast it to person, right? Because when you use read object, it can be any object, right? But this is an object of type person. So you need to cast the read object to person in order to be able to understand what is the data, all right? So is that okay for you? So once you know how to use this, you may notice that the best way is still to use this serializable, right? So serializable is accepted as one means for you to actually do binary data, all right? So if you want to implement binary data, one of the easier way is to actually write the class whatsoever, but when you save the data, save it entirely, right? One of the penalties is that it is going to be according to what you have in your object, right? If you're going to save object by object, that's fine. But if you're going to save continuous object, then the size will be bigger. All right? Okay, so hopefully you get the idea. All right, any questions? So that's the first part, and I'll stop over here for you to try out first.